You know, the very basic quantity in Newtonian mechanics is linear momentum. And it's a vector. It's simply mass times velocity. And please do never feel shy. No matter how naive the concept is, please raise your hand and ask questions. This is the thing that I will force you to do over and over again. Because I was a grad school not long time ago, and I know how shy we can be, right? And basically, if everybody is shy, they all get out not understanding anything. Okay? Please feel free to ask questions anytime. So linear momentum is simply mass times velocity, both are vectors. And Newton's law is that the d by dt for linear momentum is the force. I should have stated that Newtonian mechanics is concerned with a particle. Here is a particle of mass m has a position vector r with respect to preferably an inertial frame, but this frame has to be a Euclidean space, flat space. It's not a curved space. X, Y, Z, like this room that we live in now. So actually this linear momentum is mass times velocity, which means the velocity is the rate of change of the position, right? And it's m dr by dt. So whenever I write r dot, any dot means with respect to time derivative. So this guy is simply p dot, right? Which means is that, as all of us know, if the mass is constant, this gives you F equals ma or mr double dot. Okay? Any question about that? Any question? This guy's working? No? Very important concept here. This derivative, d by dt, has to be with respect to an inertial frame. So just to emphasize that, in the very first few lectures, I will write dr by dt and put superscript n, means with respect to an inertial frame, i.e. this is the absolute velocity. Okay, this guy. The same here. This derivative is with respect to an inertial frame. We're going to talk about that in more details now. So, for example, here this is an inertial frame N1, N2, and I have a rotating frame Ij that at this instant is making an angle theta, but this theta is function of time, so it's a rotating frame. Okay, Ij, and I have a vector A. This vector is 3i plus 4j. Anybody didn't get the description of the problem? I have an inertial frame N1 and N2 fixed, and I have another frame called Ij. It's rotating with respect to that inertial frame. And I have a vector A. Vector could be the velocity, could be position, could be anything. A vector, it's written in that rotating frame. It's 3i plus 4j. What is dA by dt? And of course, I am asking about with respect to inertia. Or let's make it like this. What is dA by dt? Is 0? Because it's just constant, right? You differentiate with respect to time, there is no time. Is it 0 or not? Anybody doesn't agree that it's 0? Anybody agrees that it should be 0 because there's no time? Yes, as many of you indicated that shouldn't be 0. Why? Because yeah, A as a vector is 3i plus 4j, something like here. So it has a fixed length. But the issue is that this I and j rotate, so A will rotate with I and j. So A as a vector quantity is described or represented by a magnitude, the length, which is constant, it's 5, but direction also, right? So yeah, this vector will not be changing its length, will always be like this, but will be rotating with I and j. So it's not, its time rate of change is not 0. It is changing. It's changing its direction, not the magnitude. Okay? Similarly, you can have maybe A equals 10t squared I. We can ask the following question. What is dA by dt? It is simply differentiating this guy only, 20ti. So, what do you think about this?
You take the root of I.
Exactly. You're totally right. Have something to
I'm just thinking.
Okay. So yes, it says if you have 10t squared times I, this quantity, the component 10t squared is changing with time. Yeah, it makes perfect sense to differentiate it. Let's multiply by another quantity, I, which is time varying. I is actually I of t. Okay? So I have to differentiate this times I, like here, but I have to add 10t squared times di by dt for I dot, right? So what is I dot? This is the thing. How to differentiate the basic unit vectors. Okay? Let's do it here. Any questions so far, please? If you have any questions, like I said, no matter how naive it is, because we have a large number of students, so might not be clear enough. Is there a question here?
Ron, you said that these Newton laws, they are valid for the inertial frames mostly. So they are valid only for the inertial
No,
frames?
this is a good question. It's a very good question, actually. This derivative, or if we are talking about Newton's law, which is this guy, precisely, this derivative, likewise, these two derivatives, has to be, must be with respect to an inertial frame. Okay, this is the basic. So if you are writing it in an inertial frame, well, that's easy, just differentiate the components. But if you're writing it, which is most of the time will be, writing it in a rotating frame, then it's not that straightforward, and we need to do some other things, which we're going to talk about now. So let's say we have here, again, well, we can modify this. So this is I of t at this time, j of t. So in an infinitesimal time, this theta adds delta theta. So this guy rotates a little bit by delta theta. I'm just exaggerating, of course, the drawing. So this is delta theta. So this is I of t. Now I have I of t plus delta t, right? Why I'm doing that? Because I'm interested in getting I dot, which is di by dt, of course, with respect to an inertial frame. Anybody remembers what is the basic definition of derivative, d by dt? What's the basic definition of derivative? The limit, exactly, yeah. I'm very glad to hear this word first, and then we can figure out the limit of what? The limit as t goes to 0. Yes, the delta t goes to 0 of what?
I
Yeah, the new thing, right? And
minus I
minus the whole thing. So the change in I, delta I over delta t, this is the derivative, right? Delta I over delta t, this is di by dt, but the limit as t goes to 0. So delta I by delta t, okay? Any question about that, please? Yes?
Sorry, I want to go back a little bit.
Yeah, sure.
The previous one where root of a equals 2b by plus 10
T squared times I dot,
I
which
dot.
I don't know what it is now. We're driving it.
okay.
Okay. Okay. So what is I of t plus delta t? So this is the limit as delta t goes to 0. What is the new I? What is that green I? What's that new I? It's actually the addition of two vectors. The old I plus this blue dotted one, right? Plus the old I, and I urge you, just bear with me for a minute, I'll leave you some time to write. The old I, let's put it in blank, like we have, plus the dotted blue. What is this dotted blue? Well, it's a vector, has a magnitude and direction. What's its magnitude first? What's its length? Can anybody give me its length? This is a rotation, right? So it's like r times the angle, the radius times the angle. What is the radius? It's the length of I. How much is that? How much is the length of any unit vector? Is 1, right? So this is actually 1. So this is the radius times the angle that you're rotating by. What's the angle that you're rotating by? Delta theta. So 1 times delta theta. This is the magnitude times the direction. Anybody can tell me what is the direction of this blue dotted vector?
Since delta theta is
It's
very
J.
small, it's perpendicular.
Yeah, it has to be exact. It has to be perpendicular to the instantaneous I, which is J. Great. So we got this new I. This is whole as new I of t plus delta t. And we're subtracting the old I again, right? Divided by delta t. And you can see, luckily, these i's go away. And you end up with what? Here's J, and you have delta theta divided by delta t. Delta theta divided by delta t, the limit t goes to 0. What's that? Delta theta divided by delta t. Rate of change of what?
Angular.
Yeah, rate of change of theta. So this is simply theta dot times J. So d by dt of I is theta dot times J. And actually, if you do the same for J, dj by dt, you will find negative theta dot I. Okay? Any question about that? Give you some time to write here. Think about it. If you have any question, please never hesitate.